I will be reporting on principles of multispectral remote sensing, focusing on Earth observation, satellites, and environmental monitoring. So let's have an introduction to remote sensing. Remote sensing involves acquiring information about Earth's surface that uses sensors mounted on satellites or aircrafts without direct contact. It captures data in various spectral bands. It supports applications in agriculture, forestry, climate, and more. So what is a multispectral remote sensing? It captures data at specific wavelength that ranges across the electromagnetic spectrum, that typically visible in near infrared, NIR, and shortwave infrared. So it allows the detection of features not visible to the human eye. It is essential for differentiating materials and monitoring environmental changes. It strikes a balance between data richness and manageability. It's widely used for environmental monitoring. It offers better material differentiation than panchromatic, but less complex and heavy than hyperspectral systems. So there are observation satellites on Earth. There are key satellites that is equipped with multispectral. One is Landsat, and other one is Sentinel and MODIS, MODIS. So several key satellites. And others key several satellites. So Landsat offers 30-meter resolution across 11 bands and is great for long-term and land cover analysis. It has a decades of multispectral Earth imagery. Sentinel-2 provides higher resolution and more frequent coverage, ideal for agriculture and disaster monitoring. It has a high resolution and multispectral data for land monitoring. And MODIS it captures daily global data at coarser resolution, perfect for large-scale changes like vegetation and climate. And it has daily global coverage that supports climate and vegetation studies. And others, Worldview. It's a commercial satellite that offers very high detail and etc., like Resource 2 from India. And each satellite has strengths. Some focus on the detail, others on frequency or area coverage. Together, they give us powerful tools for monitoring Earth effectively. Spectral bands and their uses. Common spectral bands in multispectral imaging: blue, green, red, near infrared, shortwave infrared, blue with water and shallow depths, green with vegetation health, soil and vegetation for red, near infrared for biomass and vegetation vigor, shortwave infrareds for soil moisture and snow or clouds. So they both play a big role, different roles in how useful multispectral data for environmental monitoring. Spatial resolution refers to the size of each pixel on the ground. Higher resolution like 10 to 30 meters. Let us see more detail, which is more important and for monitoring small farms. Spectral resolution means how many and how narrow the wavelength bands are. So especially in near infrared or shortwave infrared helps us detect subtle differences like healthy versus stressed crops or clean versus polluted water. So the better the resolution, both spatial and spectral, the more accurate and detailed our environmental insights become. Some applications in environmental monitoring. Multispectral remote sensing supports deforestation tracking, agricultural crop monitoring, water quality assessment, urban expansion analysis, and natural disaster assessment like floods and wildfires. So it helps us monitor the environment by capturing light our eyes can see. For example, we can track vegetation health using NDVI, which shows how healthy or stressed plants are in water bodies. Different wavelengths help detect pollution, algae, or changes in clarity, which is important for water quality. And when it comes to cities, multispectral imagery reveals how urban areas expand by highlighting differences between natural and built-up land. This data gives us clear, timely insights for better environmental management and planning. Some comparisons of multispectral satellites for Landsat and Sentinel. Landsat with 11 spectral bands with visible near-infrared, shortwave infrared, and thermal. While the Sentinel has 13 spectral bands with visible, also has a near-infrared, red edge, and with SWIR or shortwave infrared. The spatial resolution differs from the spatial resolution of Landsat is 30 meters, which is optical, and 100 meters for thermal, while the Sentinel is 10 meters to 60 meters, depending on the band. And other data that is compared with other satellites, like MODIS, with 36 spectral bands that is visible to thermal, from visible to thermal IR. And how sensor characteristics influence monitoring effectiveness. Of course, we need a spatial resolution that detects field level crops, urban details, and low spatial resolution that's best for regional and global changes. Temporal resolution or the revisit time, it's daily to weekly, monthly, and for others. For daily to weekly, it enables real-time monitoring like floods. And spectral resolution, more bands, trade-offs, etc. So supporting decision-making, multispectral data helps policymakers and scientists monitor and mitigate environmental changes, plans sustainable urban and agricultural development. It responds to climate change impacts, inform conservation strategies. In conclusion, multispectral remote sensing is a powerful tool for understanding and managing Earth's systems. Its integration into environmental monitoring leads to informed, effective decision-making for sustainable future.